Hi kids, May-June 2012 paper 4 exam. I'm going to do the solutions for the old exams. I think this will be a great way to hit a couple of birds with one stone, because old exams do cover a variety of topics, and by doing all these exams we can not only cover the variety of topics but at the same time do the exams with confidence. So always don't forget to write your name on the exam. And just briefly just going over some few things. So always read the instructions first, just so that you get practice when doing the exams. And notice that it doesn't say anything about a graphing calculator, and for that reason don't assume that you can have a graphing calculator. So what we have here is question number 1. Anna, Bobby, and Carl receive a sum of money. They share it in the ratio of 12, 7, and 8. Anna receives $504. Part A, calculate the total amount. When seeing ratio questions like this, always look at what the total amount of the ratio is. So kind of like in the vectors questions, add all of this to get a total amount, which is going to, in this case, be equal to 27. So each of these components are out of 27. So for example, Anna's share of the total amount of money would be 12 out of 27. This is for Anna. For Bobby, it would be 7 out of 27. So whatever piece of the pie it is. And for Carl, it'd be 8 out of 27. When you add each of their individual shares together, you get 27 out of 27. So looking at it, if Anna receives $504, this implies that she's getting 12 out of 27 out of some unknown total amount, which equals to $504. So the question is, what is this unknown amount? So the 12/27th of this unknown amount, and we can now use the variable x, but I'm putting a question mark just because I want you to think about that's what we're trying to solve, is the amount we're looking for. So if she's receiving 12/27th of this unknown amount, and that happens to equal to 504, we have to solve for x. So using your calculator, and the answer would be $1,134. If you're unsure about this topic, and I'm going to do that as I go along, is this particular topic for more information would be on page 168 for this particular question number 1. In case you're unsure, you can look at that just to have a revision before you continue. I'm going to move on to the next question. Anna uses 7% of her $504 to pay a bill. Calculate how much she has left. Now, if she's using 7% already from her 504, then what is left over? Well, if we look at this out of 100% and she uses 7%, then what's left over is 93%. So what we can then say is that whatever she has left over is 504 times 93%. And notice I haven't written 93 over 100, is directly have given the decimal, which then works out to $468.72. And if you want to expand on it, if you want to know how much, so this is how much she has left. If you want to know how much she has used, then it would be the same thing, except you would say 504, but then times 7%. Which would work out to 35.28. And if everything is correct, these two should add up to equal to 504. So this works out. On this part, she buys a coat on sale for $64.68. This was 23% less than the original price. Calculate the original price of the coat. So if this is the final result after the discount, then we could say that 64.68 equal to some original price times the discount would give us that 64.68. In this case, we don't know what the original price is, so I'm just going to call this OP but we know what the discount is. The discount is not 23%, but the discount is, if it's 23% less than the price, that means that we're actually taking 77% of the price. Be very careful how you read discounts. 23% less than original price means that it's 77%. If it was 50%, then it'd be 0.5. If it was 80% less, then you would be taking 20% of the original price. Be very careful how you read this. Do not do this. Don't put 0.23 here. But remember, this, if it's less than the original price, that means it's less than 100%. So 23% less than 100% would be 0.77. Which is equal to $84. Bobby uses $250 of his share to open a bank account. This account pays compound interest at a rate of 1.6% per year. Calculate the amount in the bank account after 3 years. Give your answer correct to 2 decimal places. Now I know 2 ways to do this. I know one way which is a recursive method where you calculate for 1 year, then you calculate for 2 years, then you calculate for 3 years, and another way where you can actually plug and play into a formula and get the answer directly. Let's look at without the formula. Let's look at the manual way first. So if account is paying compound interest at a rate of 1.6% per year, we're expecting that his original amount is going to increase. So this is not some kind of deduction, but it's an addition to his original amount. So this means that 1.6% is going to be added to the original $250. So in year 1, 250 times 1.016, it's going to equal to 254. That's year 1. Now if you're wondering how I got the 1.016, think of it like this, that we're taking the original 100% and each year we're adding another 1.6% on top of it. Now if you convert this in decimals, this is like 1 and this is like 0.016 when you convert it, and then when you add these together you get 1.016. Okay, so that's year 1. Now because it's compound, we have to reinvest this into year 2. And that would be our final answer, $262.19 after 3 years of compound interest. Now let me show you another way which is quite fast, and the good thing about the second method I'm about to show you is, let's say if you had more than 3 years, say you had to do it for 10 years or 20 years, or how much this process, iterative process, could take quite long. Or if say you were asked to do this at 1.7 years or something that's a non-integer, like a non-clean integer value, then it could be quite hard to do this kind of iterative process. So here's a formula that's great. And if any of you go into areas of finance, this formula will be quite useful. And the formula is FV, so future value, is equal to principal times 1 plus interest to the power n. So n is your term. So in this case, our term is 3 years. I is the interest, which is 1.6%. Principal is the original amount. And this is the final amount. So using this formula, FV then is equal to 250 times 1 plus 0, and always convert this part to decimals to the power of 3, and just simply compute into your calc. And if you do this correctly, you'll also get 262.19. See, a lot faster, just a one-step process, and you can do it for any amount as long as you understand the term and the interest rate for that term. Part D, Carl buys a computer for $288 and sells it for $324. Calculate his percentage profit. Okay, so first thing is if he buys it for $288 and sells it for $324, then we know that the difference between $324 and $288 is $324 minus $288, and the absolute profit is $36. Now, that's the actual profit, but we want to know his percentage profit. Now, students, this is where students will typically mess up. They may not know how to take this 36 if it's relative to the 324 or to the 288. Notice that it has to be relative to the 288 because we're talking about he's made $36 on what he had bought was originally worth 288. You can't put it on the 324 because that's what he sells it for. You have to use it on the 288 because that's what he originally bought it for, and this is the amount of money he made on top of it. So you would then say 236 divided by 288 times 100% is equal to 12.5%. It's really important that you understand which number goes here and which number goes here. Typical mistakes is not knowing what this number here is going to be. But remember, if you're doing percentage profit, then logically you have to think about, well, what did you originally buy it for and how much did you make on it? If you do it on this, then it's not exactly right because this is what you sold it for. It's not what you actually. It's not based on your profit, but this is based on what you sold it for. Question number 2. 3 boys, K, L, and M, show the course of a boat race. So these are these things that they put in the water. MK is equal to 4 kilometers. KL is equal to 9 kilometers, and angle MKL is 108. So MKL, 108. Calculate distance ML. So what they want you to do is find this distance right here. Now in a question like this, you're given 2 sides and you're given an angle. Notice that this is not a right angle triangle. When you're dealing with questions that are not right angle triangles, do not use SOHCAHTOA. Not right angle, do not use. Okay, so in this case, so the only rules then you have left are cosine rule and sine rule. So sine rule, cosine rule. Now notice little c. So in order to do this, I'm using this rule because of the following. I have side A, I have side B. This is my angle little c. And I have big side B. I am looking for side C. So I have this, which is here and here, here, and here. So I have enough information to calculate C because we know C is equal to ML. So applying this formula, so we have A Now notice I like to work it out. Try not to put it all in the calculator at once. That's a great way to make mistakes, is if you try to plug this all into calculator. Try to break it up, do this part separately, do this part, and then put it on the calculator once you've digested a lot of the pieces first. When you try to enter things all into a calculator all in one go, that's a good way to make a mistake. And avoid it. Don't try to do it all at once unless you're experienced with calculators and particularly experienced with brackets. Now it's in a form where we can now digest it. So the distance then between M and L is 10.9 kilometers. All right, in the next question, the bearing of L from K is 125 degrees. Calculate how far L is south of K. So the bearing of L from K. So this means that if the guy at K or whatever is facing this way, to get to L, you have to turn 125 degrees. And ask how far is L south of K. So how far so if K is here and L is here, it doesn't ask you how far K is from L. That's not what it's asking you. It's not asking you this distance. It's asking you how far south do you have to go in order to reach L. So meaning that if you went this way and then you went this way, this is the distance you're concerned about. So how far south you have to go, not how far you actually have to go. So what we can do is we can create a triangle. And notice it's the right angle triangle. So what we're looking for then is this distance right here. And in order to get this distance, we can use, now since it's a right angle triangle, we can use SOHCAHTOA. And to use SOHCAHTOA to get this distance, well, it will be helpful to find this angle. And we know this angle here would be 125 subtract 90. Because if this whole thing is 25 and this is 90, this inner angle, then the leftover angle would be 125 subtract 90, which is equal to then 35 degrees. So this angle here is 35 degrees. Now what's helpful is there's no rule saying you can't redraw this. So when problem solving, it is quite helpful sometimes to redraw the situation and deal with only stuff that you have to worry, only the stuff you have to worry about, because it helps declutter what's there. So I'm just going to redraw the situation. So this is my D, this is my 35 degrees, and I have here 9 kilometers. See, when we draw this, it's easier to see under all the all the other work that we have what we're actually trying to find. We're trying to find D. We've made it into a nice right angle triangle, and let's solve for D. Now in this case we can use SOHCAHTOA, and in this case because we have hypotenuse given and we have opposite given, then it's quite we could use sine. So opposite over hypotenuse. Therefore D is equal to 5.16 kilometers, or 5.1, yeah, 16. I don't know why I put 3 there. 6. So if you're unsure about how I'm doing some of these questions, these type of questions can be found in the topics of the sine and cosine rules in your textbook, and under a topic of bearings. So if you look in those sections, you can find more practice questions on this topic if you feel this topic wasn't that easy. Part 2, it says find a 3-figure bearing from K to M. Now remember, bearings always have 3, you can say digits inside there. So for example, a 45 degree bearing would be read as 0.45 instead of just 45 degrees. So even if there's like a 2-digit angle or 2-digit bearing, you still have to tack on the 0 in front of it. So in this question we're finding the 3-figure bearing from K from M. Now it's really important that you look at it's K from M. It's not M from K, but K from M. So a common mistake I can see happening is students trying to robotically go from north and say, well, the bearing is from here to here. No, that's not the bearing. That would be M from K. We're trying to find K from M. So look at it like this then. If we were to draw M facing like this, I'll use blue just so this is like the, then M from K would be this bearing right here. Okay, that's the bearing M from. Let me just make sure I'm explaining this properly. This would be M going to K is this one, and K going to M would be this way. So notice who's rotating. In this case, K is rotating to M, which is this bearing, but in this situation, M is rotating to K. So K from M would be then this position from M. Okay? And then this would be M from K. This is K from M. This is M from K. Okay? So we need to find this angle right here. Now that we understand that, remember when you're doing these questions, you look at the number of marks, you see it's a 2-mark question. So this means that don't do any kind of complex, ridiculous kind of stuff. Try to think simple. And some of the best ways to do some of these questions is, you know, you're smart kids, use some common sense to make triangles out of stuff. If you start doing crazy long-winded solutions for a 2-mark question, you're definitely on the wrong track. And to show you what I mean, look here. 4 marks, and we got, you know, enough stuff to do for 4 marks. 3 marks, a little bit, you know, a little bit less, right? 3 marks, and 2 marks, we should then expect the answer to be a lot simpler than these two. Okay, so let's look up here. So we're looking for this angle right here. So let's do this. Let's extend this line. And if we extend this line, then make a triangle out of this line, we have a right angle triangle. We know the angle from here, here to here should be 180 degrees. So up to here, we have 108 plus 35. So from here to here, we have 143 degrees. That means that what we have left over here then would be 180 subtract 143, which is then 37 degrees. So notice, so 30, so you know this, so 108 plus the 35 here. So we have 37 degrees left over here. We have 90 here. So we know that in this triangle there should be 180 degrees. So 180 subtract 90 subtract 37 degrees will give us this angle. And this angle then would be 53 degrees. So notice how I got this 37. Look how quick it was. No calculations, nothing. Just using the geometry, knowing that from here to here should be 180 degrees. So what's the leftover angle right here? So then the correct way to write this answer is, if it's 53 degrees from north, then you would write the 0, 5, 3. And notice we're talking about M's north. Okay, so going this way, 53, 0, 5, 3 to K. Question number 3. The table shows some values for the equation y is equal to x cubed minus 2x for negative 2 is less than x less than 2. Now looking at the total number of marks for the question, 3 plus 4, 7 marks. And this question is quite straightforward. Much of it has to do with just plug and play and plot what you calculate. While you can use theorems for quadratics, you can use theorems for cubics to plot this. This is actually a lot simpler because they've given you a table of values to work with. So in this question, they actually guide you exactly how to do it by first telling you to complete the table of values. Normally, a question wouldn't give you this, and you wouldn't be expected to figure out the table of values before you plot it, or figure out some kind of data to plot it. But they're actually, by making you do part A, they're actually helping you do the question. So first step is to plug in the values of x into the equation. So plug in each of these values of x into this equation. So I'm just going to do the first one as an example, and I'm going to compute the rest from with using a calculator. So at negative x equals negative 1. So you can't compute the value 1, so we put the value 1 here. Next, compute y is equal to negative 0.6. Now always notice that when you have negative to the power of 3, always expect that what's going to come out of this is going to be a negative. When negative is to an odd power, it's always going to come out as negative. If a negative is to an even power, like 2, 4, 6, 8, etc., it's going to come out as positive. If a negative is in an odd power, it's going to, so whether it's going to be, so to the power 3, to the power 5, to the power 7, etc., it's going to always come out as negative. So expect that the result of this, and notice how I'm using the brackets. Please use the brackets. So the result of this, if you put in your calculator correctly, will be 0.984. So that's the value here. Next, 0. So here, the value is 0. Next one, 0.6. And here we have negative 0.984. Y is equal to 1. So here we have then negative 1. So now we've completed the table of values for part A. Now at part B it says, on the grid below, draw the graph of this function, so the function we've just done, between 2 and negative 2 and 2. Now notice that our intervals here go from negative 2 and 2, so what they're basically asking is plot these points from negative 2 and 2, nothing else more to do. They've also plotted the first 2 points for you. Now why did they do that? There's a reason they did that for you, is to see how they have divided up the range. So you have an idea of how to divide up the range. They kind of give you a hint of how they've done the division, particularly with this one right here. So we can see we have the first 2 points at negative 2 and 4, which is this one right here. And then negative 1.5 right here, and negative 0.38. So this point here at this gray line is negative 0.38. Now, to be very accurate, notice that if you look at this right here, this goes up 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 0.10. So they're all going up an increment, or going down, you should say, in increments of 0.1. Okay, so this one being then 0.4, and this one being, so 0.5 would be then, so 1, 2, 3, 4, 5. 0.5 would be right there, just for your reference. So the third point we can see here is at negative 1 and 1. So negative 1 and 1. So we'll point here, I'm going to use a different color. The second point's at negative 0.6 and 9.4. So if these are, so here is negative 0.5. Because the distance from 0 to negative 1 is 1 box here, and the distance from 0 and negative 1 this direction is 2 boxes, then you could say that this is, let's say the increment of 0.1 is every 2 lines. So if 0.5 is here, then this won't be 0.6, but this will be 0.6 right here. And y is 9.8. So this is 1 box, so this is all increments. So this is close to here. Now we can see by comparing points that negative 1.984 and 1 are really close to each other. So we do then expect then this point to be quite close. So we expect the point to be around here, very, very close. And it would be correct, because this is going down, each increment is 0.1, so from here, this would be negative 0.4, negative 0.3 would be right here, because this would be the negative point. And how do I know that? Well, if 2 boxes are increment of 0.1, 0.1, 0.2, 0.3. This is my negative 0.3, and the point we have there is 0.57. Which we expect to be midway on this side. I should make it not like, I'll make a line like that, not a point. So we expect this to be halfway here. So going up vertically, each box is increment of 0.1, 0.1, 0.2, 0.3, 0.4, 0.5. And so we have a point, another point right here. I'll make them blue. Stay consistent. The next one's quite easy, 0, 0. So that's just right here. Now notice that at point, so this graph is starting to look like it's self on the other side, but in a different kind of way. Notice the points are repeating, but on the other side. And with negative values. So at point 3, we got negative 0.57. So now you're almost kind of drawing. So look at this side and then kind of map it onto this side in the same way. So going this way, each increment is every 2 box increment 0.1, 0.1, 0.2, 0.3. We're expecting 0.57 to be closer to 0.6. So from here, each increment is 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, and then 0.6. So a little bit closer to 0.6. And maybe I should draw this a little bit closer to 0.6 up here. So this is all about just being careful. At x equals 0.6, so this was 0.3 because every 2 boxes increment 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. And we're expecting a value of negative 9.84, so close to 1. Let's go down this way. The next point is 1 and negative 1. So this one's quite straightforward. The point after that is 1.5 and 0.38. So remember, every 2 boxes this way is increment 0.1 this way. So 0.1, 0.2, 0.3, 0.4, 0.5. So this is 1.5. And we're looking for the value of 0.38. And watch that 0.38 is positive. And going this way, every 1 box is increment 1 going up. So 1.1, 0.2, 0.3. And because 0.3 is closer to 0.4, so we have a box right there. And the very last, 2 and 4. So 0.2 and then 4 is up here. So now we've plotted the points. Let's connect the dots. Now I'm going to attempt to make this smooth, although on this tablet, it is quite hard to draw on this sometimes. And that would be your graph. And that's 7 marks collected just by being patient and careful. Turning the page, what a great thing. Actually, this question does continue on. And notice that we have another 4 marks we can collect right here and right here. And actually, no, this is actually quite nice. We have 7, 10, 13. This is like a 14 mark question, and it's quite straightforward. Okay, so you should be able to do this. So let's look at this part of the question. On the grid, draw the line y equals 0.8 for negative 2 is less than or equal to x. So this is just telling you where you should draw this line between what x values. So if this was 2 and this is negative 2, you want to draw a line y equals 0.8. So this is going to be at 0.8. Okay, so let's do this on the grid more directly. So then looking at this graph, y equals 0.8 then would be, So if this is if every one is increment, every block's increment 0.1, 2, 3, 4, 5, 6, 7, 8. So this is 0.8. And therefore we have to make a line. So making a straight line from -2 to 2. And this would be your y equals 0.8 line. On here it says use your graph to solve x cubed equals 2x, x cubed minus 2x equals 8. It says use your graph, okay? The reason why they're saying is because, and remember, look, the number of marks. See this first one, see that last one we just did was just 1 mark. Wasn't that easy? And obviously 1 mark for it. We just drew a straight line, boom, 1 mark. Now in this question, use your graph. Follow the instructions. It says use your graph. They're probably giving you a hint that if you try to do it any other way, you're just going to make your life difficult. So let's use a graph. So if our original function was y is equal to x cubed, this is the function we're given. Now notice something. This is x cubed minus 2x is equal to 0.8. So if I look at this, this is like saying x cubed minus 2x is equal to y. Therefore, y is equal to 0.8. So then what are they asking? They're saying find all the x values where y is equal to 0.8. So let's pretend if we had a graph that looked something like this. And we had a y equals 8 line like this. So what they're saying then, if this is 0.8, y, this line right here, then find this x value, find that x value, and find that x value from the graph. So let's do it. Okay, my previous line disappeared, so I'm just going to redraw it quickly. This is y is equal to, so we have this. So the point of intersection is where this occurs. So there's an intersection right here. There's an intersection right here. And there's an intersection right here. So what are those x values at these points? So looking at here, the very left hand side, we know that 2 boxes increment 1, so -1.1 and -1.2. So the value of x is between -1.1 and -1.2, because 2 boxes represent increment 1. And to be more, this would be -1.15, to be more exact, right here. Okay, looking at this point right here. Now looking at this part of the graph, I should have drawn this line a little bit closer, because this was 0.984, which is closer to 1. So this line should be connected more like this. So the graph actually would intersect around here. Right, so this would be the actual intersection. See how it's really important just to be really careful with neatness. Graphic tablet, a bit hard to make this very accurate, but note this should be there. So this is the actual point, and this point of x then is between -0.3 and -0.5. So right here. Okay, these are the points we're focused on. Just be very careful with this. And looking here, we have a value greater than -0.15. So this point here, we can say x is between 1.5 and 1. Or you can write the interval and that would be how you do that one. So in this question, as long as you pick numbers within those intervals that I've shown where the x value could lie, then your answer would be right. So we could say then first one was -1.15. Second we could say was -0.3.
5 or so. More, I would say more like 0.4. And the third one was just a little bit above 1.55. And that would be 3 marks right there. So the next question, it asks you to find the tangent line at the point x is equal to negative 0.5. So here what we have is x is equal to negative 1.5. Now notice I've zoomed in. I've zoomed in because I want to draw a tangent line. Now, always in mathematics, you'll learn, particularly later on when you get to calculus, that the best tangent lines, or the best way to estimate a tangent point, is to find the rise over run over the smallest area near the tangent line. So do not try to make large tangent lines and then find the slope, but the most accurate tangent lines are the ones closest to the point, where the two endpoints are closer to the point. So notice what I'm going to do here. This is the point. So what I'm going to do is I'm going to make a tangent line that touches this point and goes up to there. So now I have my rise, my run. Simple tangent. This is a very accurate way to do it. Notice I didn't draw it really long, but I've just done this. So let's look at the height then. Look at the rise over run in this case. So we know that going down, each box down this way is 0.1 and 0.1. So this height here is 0.2. And we know that going on the x-axis, that every 2 boxes is increment 0.1. If every 2 boxes increment 0.1, that means one box is, if 2 boxes is 0.1, then what would one box be? One box would be half of that, which is 0.05. So then our slope, or our gradient, would be rise over run. So then we would do 0.2 divided by 0.05, and our m will then equal to approximately 4. Note this will always be approximate until you get to calculus and learn about derivatives, which is later on. You won't get an exact value. You'll always get an approximate until you learn techniques later on to get the exact value. But this would be the answer for that question. You could draw, just keep in mind, you could draw longer, you could draw a larger triangle, but the best way to approximate a gradient when you don't know calculus is to make the smallest rise over run intervals and solve it, and make sure that hypotenuse here touches that point, and it acts like the tangent line. So then in this case we would write the gradient is equal to 4. And it's probably best to write approx. And that's 3 marks right there. Question number 4. So what we have now is a question based on circle theorems. If you have difficulty in this section, remember this section starts on page 294. But this section, and I want you to understand that although you see plenty of theorems, you see plenty of stuff in here, keep in mind that these kind of questions, all geometric style questions, can always be done using a lot of common sense and stuff the basic stuff you already know about angles. You actually don't need to memorize all the theorems or need to know all these theorems if you use your common sense. Now the topic that we had done on vectors can also significantly help you do questions here, but understand this is a very much a common sense type of topic. So looking at part A, okay, part A saying find angle ABC. Notice one thing, 1 mark. 1 mark means don't start doing a lot of crazy stuff. Okay, try to search for the easiest solution. So look at angle ABC. This right here is angle ABC. This part here is 77 degrees, and notice here we have a right angle. So angle ABC is just 90 degrees. In part B it says calculate angle ACB and show that it rounds to 35 degrees, correct to nearest degree. Notice the word here, the difference between this. Here it says find it. So find it. It doesn't say doing any calculation, it says like search for it. Whereas here it says calculate. Calculate gives you the indication. Remember reading these questions, calculate gives the indication that you're not going to find something, but you're going to have to like manipulate numbers. You're going to have to punch things in the calculator, do some math. Okay, so let's look at what calculate and how we calculate it. Looking at angle ACB, angle ACB is this angle. But look, we have a right angle triangle and we need this angle. So let's just draw this to see the picture better. So what we have essentially is we have this is the situation. We have this angle, we have this side, and we have this side. Do we have enough information to calculate this angle? Definitely. Because it's right angle, we can use SOHCAHTOA. So looking at this, we have opposite and we have adjacent. So we can say tan theta is equal to opposite over adjacent, which is therefore equal to 7 over 10, which is then equal to 10 tan theta divided by 7 over 10. Theta is equal then tan inverse of 7 over 10, and therefore theta is going to equal to 34.99 degrees. See, that easy. And I highly recommend that when you're doing a lot of these circle theorem questions, try to see if you can use sine rule, cosine rule, SOHCAHTOA, you know, because you're going to deal with a lot of triangles. And you know, if you're like me where you don't like memorizing things, or you don't like to memorize a whole list of theorems, use common sense, use logic. So far we've used logic, we haven't used anything special on the circle theorem question to solve the question. And this is an exam question. Okay, so in part C, because it's a 1-mark question, we will use a theorem. A very easy way to look at it. When you're looking at theorems, visualize it. We could prove it algebraically, but for 1 mark, why go through all the trouble? So let's look at one straightforward theorem. Okay, looking back at this question right here. Okay, this is what I want you to see. I want you to imagine that these 2 points here are fixed. Okay, these 2 points are not moving. Okay, now I want you to imagine C rotating, going this direction. Okay, if you were to take this point C and move it, what's going to happen to this triangle? What you're going to notice is if we move C this way, this angle here is going to start getting bigger, right? This is going to get bigger, and this angle here is going to start getting smaller. But what's going to happen is, although this angle will get bigger and this angle will get smaller, this angle here will remain unchanged. Okay, this is key. So imagine the C being moved, this point, keep these 2 points fixed and move the C this way. What's going to happen is these angles inside here will change, but this angle here won't change. Likewise, if you take the point D and move it this way, this angle here will get smaller and this angle here will get bigger, but these angles will not change. And it doesn't matter where you're on the circle. If you start from these 2 fixed points, the angle won't change. So if I made up another point, let's say I made up a point here, F, and I connected these 2 together. I'll use a different color to represent this. What's going to happen is, let me make it more nice. This angle here is also going to be the same. This angle here will also be identical to these 3 angles. So no matter where you go on this around this circle, or also called an arc, this angle will stay fixed. While these angles will change. So these angles here change, but these angles remain fixed. Okay, so if these 2 points are fixed, the angles here, if the point is fixed here, the angle at this point will remain fixed, and that's why these angles are the same. Now you can prove it algebraically. For example, we found this angle in the previous question. We know this angle will be 112. We could also prove it algebraically, but that's more work. For a 1-mark question, it's a lot of work. So we can use this theorem instead. So try to imagine movement occurring. Okay, so try to imagine like this animating and it overlapping each other, etc. But note that you can do it algebraically. You could use sine rule, cosine rule. You can solve the value of this angle and compare it to the value. So you can solve this angle and compare it to this angle, and it can be done. But for 1 mark, why go through all that trouble? So the particular theorem, the circle theorem in this case, is as follows. Okay, first of all, the answer you would say would the point lies on the arc. So you could say this is the arc, And because it's based on these fixed points, that's why this angle does not change for what I've just explained. But the actual theorem is more like this. You can draw a picture, you might as well. So if we have two fixed points A and here B, and we say we had point C and D here, connecting these two connected, right? So this connected from here, this connected from here, from the two fixed points. This angle theta is equivalent to this angle theta. Theta 1, so theta 1 would be equal to theta 2. Because no matter where we move it, it's only these angles that will change, while these angles remain fixed. Okay, so that's a quick way for the theorem, but it can be proved algebraically. If you want to see more about this, this is on page 304. Okay. There's 4 main properties and the rest are implementations of this property. But I really want you to try to do this with a lot of common sense. And remember, if the question is worth a lot of marks, chances are you're going to have to use like sine rule, cosine rule, SOHCAHTOA, etc. If the question is worth a small number of marks, you probably have to just go straight on regurgitating a theorem. So now we're going to calculate length AD. So I'm going to refer back to the original diagram. I'm going to clean up the original diagram and we're going to see how we can do this. It is a 3-mark part. So, and notice that it says calculate. If it says calculate, you got to do the math. So I'm going to erase it, the previous one. And this is why sometimes, oh, oops. Okay, I'm just going to go with a fresh one. Okay, so note the following. I'm going to now put on the following previous information because you're going to need the stuff you've calculated before to do this question. So we've determined that this angle here is 90 degrees. So if this angle is 90 degrees, what's left over? So then this would be 13 degrees. We've also calculated previously that this was angle 35 degrees. Okay. We also determined previously that this angle is the same as this angle. So this is also 35 degrees. Now notice that even if you weren't able to explain the circle theorem, so this is an interesting problem solving technique, like strategy. Look, say you weren't able to get this question, but notice that they told you the answer anyway. So although you had solved ACB previously, and just pretend that you weren't able to determine why ADB is equal to ACB. They've already told you actually that ADB is equal to ACB. So in the next part, even if you didn't solve this question, you could still assume that this angle is the same as this angle because they told you that. Do you see what I'm talking about? So you could still do this question even if you weren't able to do part C. Okay, so this is the information that we have. That means that the angle here would be 180 subtract 35 subtract 13, which is equal to 132 degrees. As a result, this side also will be 132 degrees. Now, because we expect in a circle there to be 3, because these two are even, automatically these two will become even. And so if we know that we have 264 degrees over here, then what's left over? So 360 minus 264 is equal 96 degrees. So 96 degrees divided by between both of these. So we have then therefore 96 divided by 2, which is going to be 48. So we have 48 degrees here and 48 degrees here. So now we have enough information to solve this side. I'm going to put a question mark for this. I'm going to say this is what we want to find. So I'm just give myself some space. Now notice that we're not dealing with right angle triangles here. So if we're not dealing with right angle triangles, use sine rule or cosine rule. In a question like this, if we're trying to find this side and we have 2 angles given but fewer sides, go with sine rule. So use sine rule. Sine rule is better when you typically have more angles available instead of sides. And cosine rule is better if you have more sides available instead of angles. you see the difference? More angles available goes with sine rule. More sides available go with cosine rule. So let's see what's required to find AD. So if we use sine rule to find AD, we can say that sine 132 degrees over, now I'm writing it here because I need to refer back to the diagram, but sine 132 degrees over AD, okay, sine rule, is equal to sine 35 degrees over unknown. I'll call this one unknown because we don't have this side. So we need to find AD, so let's rearrange AD in terms of AD. AD is equal to sine 132 divided by sine 35 times that unknown sine that we need. So we have now what we require to find AD. We need to find out this unknown, which is this side here. So to find this side, let's look at now this triangle here. Let's use sine rule in this because we have more angles than sides, right? We have 48 and 677. So sine 77 over unknown is equal to sine 48 over 7. So these two are together. These two are together. Rearrange for unknown. Compute. So compute the unknown. And putting this in your calculator, you can get the answer of 9.17 or so. So now we have this side right here, 9.17. Now we can take this and plug it into here. So then we can write here then AD is equal to sine 132 divided by sine 35 times 9.17. So AD is equal to, in your calculators, approximately 11.89 would be then the length of that side. And this would be in centimeters because the units are in centimeters. So summary, first write the equation of the question you're trying to solve, and then go search for all the unknowns. So what we did is we first found out what's needed to find AD. We found out that we need this unknown, and then we went directly and attacked for that unknown. So that's what don't start finding this unknown because you don't know what's required to find AD. First look at what's required to get the AD, and then go after those variables. So we found what's required to get AD, which was this question mark, and then we went after that question mark. Now notice that the first half of this exam is actually a quite meaty and a time-consuming part. You'll notice in the if you skim through the rest of it, the rest of the questions are actually a lot quicker. So this exam was designed in such a way that you spend a lot of time at the very beginning. I guess part of it is to stress you out, and then toward the end, you're probably going to end up moving really fast. So you're going to be slower at the beginning and fast. That's how this exam seems to be designed, from what I'm looking at. In the next part, it says calculate the area of the triangle ABD. Now remember, in all triangle questions, you're doing base times height divided by 2. Or alternatively, half base times height. So now referring to the previous diagram. And just before we do that one, just don't forget to write the answer inside here. So we knew it was 11.9. Okay. Now area ABD. Okay, so in this question we're trying to find the area of ABD. We know that area is equal to half base times height. Now when you're doing a question like this, you have to adequately determine your base and your height. Now be very careful with the height part. The height does not mean the longest side. The height, the value of a height is always the perpendicular to the base. So for example, say we just had a right angle triangle. Your height, if this is your base, your height is the line, or you can say the vector perpendicular to it. So if we had a triangle that looked like this, for example, the height would be perpendicular to the base. Okay. If we had a triangle that looked like this, for example, the height is perpendicular to base. Let me make it a little bit more. Let's make it like that. Okay. Height perpendicular to the base. Okay. Now be very careful when doing also this question. Do not assume that the area of this triangle is the same area of this triangle. Just because these angles are the same does not imply they're the same triangles. Okay. For this reason.
you could have a triangle that looks like this, right? And you can have a triangle that looks like this. Both triangles have this angle, agreed? Yet we know the area of here and the area of here, the whole thing is not identical. This small triangle and the big triangle, they're not identical, although they share the same angle. So do not assume that the area of this one is the same just because the angles are the same. So don't make that mistake either, and don't make the base height mistake, the height mistake particularly. Okay, so those are two key areas to watch out for. Now this question is a lot easier than it looks. So if we want to find the area of this DP, we need to find the height. So if this is our base given 7, we need to find a line perpendicular to this base. So what I'm going to do is I'm going to draw a line perpendicular to the base from here. So this is perpendicular right here. When we look at what was given, we knew that this was 132, this was 132, this was 48, and 48. So we can find out then what this piece of the angle is, which is 180 minus 77 minus 48. So that piece is equal to 55. So here's 55. We knew from the previous question this was 35, therefore this whole thing is 35. As a result, we can find what this piece is here. So we can say then 180 minus 132 minus 35 is equal to this piece, right? So looking at this interior angles of this triangle. So here we have 13 degrees. Now looking at this triangle here, right? This triangle is going to help us get the base, the height. So this entire angle here then would be 68 degrees. So if this is 68 degrees, we know from the previous question we had solved this, which was 11.9. So now we have enough information to solve this height using, now because it's a right angle triangle, SOHCAHTOA. So in this case we can just call this opposite for now. So we have sine 68 degrees is equal to opposite over 11.9. So opposite is equal to 11.9 times sine 68. We know this is equal to our height. Right, so this is the height. So now we can say area is equal to half base times height. We know base is equal to 7, which is down here. We have height is equal to 11.9 times sine 68. So therefore area is equal to half base 7 times height. So now compute this all in your calculator, and then the result you will get is 38.6, and because it's area you would write this in centimeters square. So that's the answer for the area. So here we have then 38.6. And the next question is the area of the triangle AED is equal to 12.3 centimeters square. Correct to 3 significant figures. Use similar triangles to calculate the area of triangle BEC. Okay, so similar triangles. So when we see something like this, we're thinking about proportion. Proportion, yes. And calculate, meaning we got to use math. Use math, calculators, etc. Okay, this gives you a hint of the kind of process or procedures you're going to have to do. Okay, so I'm going to go back to the other diagram to show you how to do this question. Now, out of all the questions that were in this particular circle theorem style or the circle question, I believe E is actually the one that requires more intuition and more problem solving skills. So the question fundamentally has given you this, and it's fundamentally asking you, if you're given the area of this triangle and given this base, using ratios or proportion, how can you find the area of this? And be careful, do not assume they're the same areas. We know that the angles here are all the same, but that doesn't mean the proportion. And the quick way to know is that, look, this side is 11.9, this side's 10. This triangle can no way possibly have the same area simply because its base is completely different, given the fact that we also have the same angles. Okay, had the angles been modified, then yes, a variation in height and a variation in height could give the same area. But in this case, we have all the angles are identical. These angles are all the same, but the base are different. This area will be different. So what I'm going to do is I'm going to draw this in a way that will make it look a little bit more intuitive. So this is actually the situation we have where this ADE is the bigger one. So ADE, or actually, well, let's make this E instead. We don't even need the letters. We can just look at it. Just know that this is the bigger one and this is the smaller one. So we know in this case the base is 10, and in the bigger one the base is 11.9. Their heights are here. We know that all these angles are the same, and just in case we're unsure, just remember this is 35. That was 35. This was 132. 132. This is 13 and 13. This we determined from the previous questions. So knowing that, that means that this angle here is the same, this angle is the same, and etc. Now to do this question, the key thing is to see as well, how much bigger is this compared to this? So if we divide, for example, 11.9 by 10, we find that the bigger triangle is bigger by 1.9 times. So 1 plus another 19% bigger. Or we could look at the other way, how much so the bigger triangle is 1.19 times bigger than the smaller triangle. Or we can look the other way, where we can say, well, how much smaller is the smaller triangle compared to the bigger triangle? And then we could say, well, the smaller triangle is 10 out of 11.9. So it's 10 out of its total length, 10 out of 0.9, and which means that it is 0.84 times smaller, or you could say, in other words, 84% smaller than the bigger one. So it's 84% of the bigger length of the base. That's the smaller triangle relative to the bigger triangle. Or you could say the bigger triangle is 119% bigger than the smaller triangle. Okay, so look at it. So we're going to focus on this. So as a matter of proportion, in this case, if the base of the smaller triangle is 84% of the bigger triangle, then we could also, the same ratio applies for their heights. So if the base is 84% of the base of the small is 84% of the base of the big, then we expect that the base of the small, the height of the small is going to be 84% of the height of the big. So we were given, so the big triangle's base was half base times height. We were given as 12.3. We have the base in the question, 11.9. So we can calculate the height of the big triangle first. So that means that the height of the bigger triangle is 2.06 centimeters. So this one here is 2.06. So since this is 2.06 and we know that the height of the smaller one is 84% of the bigger one, then we could say, well, height small is equal to 2.06 times 0.86. 84%, not 86%, 84%, as we got right here. So the height of the small then is 1.73. Notice that we're using proportions. So now that we have the height of the small and we have the base of the small, we have enough to calculate the area of the smaller triangle. So area small triangle, or smaller, equal to half base times height. We have the base as 10 for that smaller one, and we have the newly calculated height, which is 1.73. Punching in your calc, and if you carry all decimal places, you will get 8.68 centimeters. Hope you can see this. Oh, I'm off the page. Hold on. So I'm just going to write here. So area small is equal to half base times height. So the base of the smaller triangle was already given, which was 10. So half times 10. The height, we found the proportion, which was what, 1.73. And if you carry all decimals properly, you will get 8.68 centimeters square. Roughly, keep them, if you carry a few more decimal points, and you will get the exact. So that would be the way to do it using proportions. You could do it using sine rule, cosine rule, or find the height of this, or find the height of this, and then do base height. You can do it like that, but the question asks for proportion.